In this lesson, we're going to be talking about disk drives or hard drives and different types of what we still call hard drives, although less and less they're becoming a traditional hard drive. So hard drives have been around in the PC world anyway since the 1980s, and originally they were very small, on the order of a megabyte or so, maybe 10 megabytes, 5 megabytes. Now, of course, we're talking about terabyte hard drives, and so we're several orders of magnitude higher than where we were 25, almost 30 years ago, or about 30 years ago. So there have been a lot of different types of hard drives, or certainly interfaces more specifically. There have been many different interfaces to the hard drive. We've got IDE, EIDE, there's parallel ATA, and now serial ATA or SATA. And they have allowed for access to larger hard drives in a faster way. So the throughput has certainly increased over that period of time. But primarily what we've been talking about with hard drives is we've got spinning platters that store data in a magnetic format, and you've got heads that can actually read that magnetic platter and be able to write and read to and from that magnetic platter. So we've got these mechanical hard drives that we've had for decades now. So you can actually take a look here at the different drives that are installed on this particular operating system. It says that there's a floppy disk drive, although there's not actually a floppy disk drive that's installed here. And I've got a USB drive, and I've got a DVD. Here's actually my hard drive, and it says it's an ATA device for Windows 7. It's a disk drive, and it actually gives my location here. So in addition to the ATA family of drives, we've got SCSI drives as well. We've got a pretty wide range of interfaces for these hard drives. And as I said, for a long time, they were these spinning platters with read and write heads. Now, what we've been moving to in recent years has been something closer to this drive right here is actually a USB stick, and it uses memory rather than actual spinning platters. So there's some silicon in there that allows the data to be stored and kept in a non-volatile way. And as I said, we've been moving closer towards things like that. We have these solid-state hard drives now, or you might hear them called SSDs, and that's because they're solid-state. The reason they're solid-state is they don't have the spinning platters. They have this flash memory in them that not only can speed up the interface time, it gets rid of the moving parts that could actually cause outages from failure. Now, we do have some additional risks with these SSDs or flash drives because over time they actually wear out and lose their ability to store information, but we're improving those capabilities over time and fixing some of those problems. So I'm going to show you, there's this program under Linux called SmartCTL. And what SmartCTL is something that allows you to query the SMART status. And SMART is an acronym that really has to do with the ability to interface directly with the drive and question the drive about what's going on. So you can see right here, we questioned the drive and it gave us back a model family, a device model, a serial number, a device ID, as well as the firmware version. So here we've got this hard drive, and I can actually pull back a lot of detail from the hard drive without pulling the case apart and seeing what's going on. So you can also see things like the self-test execution status, total time to complete offline data collection. We've got SMART capabilities and error logging capabilities. There's a lot of detail here that you can actually pull from the drive. So it's not just a case of dumb spinning platters like we had 30 years ago. We've still got the spinning platters, but now we can check with the drive to see what the drive thinks about its own state or status. See whether it believes it's in good working order or whether there are errors that are being generated. And it's got the ability to do self-tests to see what's going on. So while we're still using hard drives, just as we have for 30 years, we've made a lot of leaps in terms of the technology that we're using. Not only is the interface faster, in some cases the platters are spinning faster, and so the data is coming off at a quicker rate than we had 30 years ago, and the intelligence on the drives has come a really long way. As I said, you can now just query the drive to see what it is and what its current state is, because drives that you buy these days are generally smart capable.